Szanowni Państwo, zgodnie z zapowiedzią przełączamy się teraz na język angielski. Ladies and gentlemen, let's switch to English and start the second part of the first day. I invite you to join the discussion on the topic IoT in industry, smart factories of the future, which will be hosted by Bartłomiej Straszak, and his guests will be Werner Reichelt from Festo, Dr. Simon Hurst from Fraunhofer Institute, Alexander Geisler from Rion Software, and Piotr Wiśniewski from DBR77. What tools and solutions maximize efficiency? Which data is worth collecting and why? How to deal with the processing analysis? Let's find out how the invited guests will answer these questions. Have a nice time. Thank you.
Good afternoon and warm welcome to our discussional panel, IoT in Industry, Smart Factories of the Future. My name is Bartłomiej Straszak, and together with our guest, we will deep dive on IoT in industry. So warm welcome to our first panelist, Alexander Geisler. He is a graduate from Poznań University of Technology, majoring in logistics for several years. He has been working with with corporate clients and Polish companies providing IT solutions related to machine monitoring, loss analysis in the production area, and digitalization of the production process. He has working knowledge of IT ecosystem in industrial plants and technologies used in communication between systems and machines. For the past 5 years, he has been actively developing sales of Rion products, combining operational experience with business skills. Warm welcome, Alexander. Another guest on my list is Dr. Simon Hurst. He's a business unit director for cognitive production at the Fraunhofer Institute for Machine Tools and Forming Technology. Previously, he held various positions at the Fraunhofer Gesellschaft, including member of the supervisory board of Fraunhofer Austria, deputy head of Fraunhofer think tank, and scientific advisor to the president to this institute. His academic background includes a doctorate in engineering science from Aachen University, where he graduated summa cum laude in the field of manufacturing processes simulation. Dr. Hurst also, and with his team of around 45 researchers, are currently focusing on digitalization solutions for small and medium-sized enterprise, flexible automation solutions, and the development of digital twins for processes and systems. I cannot imagine a better guest for our discussion. Warm welcome to Simon.
Good afternoon.
Good afternoon. And another guest, Werner Reichelt. He's a diploma engineer in product engineering and economics from University of Applied Science from Germany, with 35 years of experience in automation technology. He has held various senior management positions in product management, industry segment management, global key account management at Festo Automation and Festo Didactic, including 17 years as a head of global automotive industry segment. Since the end of 2020, he has been head of sales digital businesses at Festo, leading a global team of sales and application experts. Hello, Werner.
Hello.
And the last person you've already probably know, but in order for our guest who hasn't had a chance to meet Piotr, a few words about Piotr Wiśniewski, founder and the global CEO of DBR77 platform. He holds PhD in management from Poznań University of Economics and completed the general management program at Harvard Business School. With over a decade of experience in managing international enterprises, he previously served as a CEO of the Matlow Group, overseeing plants in multiple countries and leading strategic initiatives and significantly improved operational efficiencies and financial performance. Currently, he leads DBR77 in process automation for various businesses through innovative digital transformation solution. Hello, Piotr.
Hi, I'm really shocked that, so long introduction.
All right, so let's keep it faster and simpler now. Let's jump straight to the questions, guys, because I'm not sure if our guests are that excited as I am, but I think after a few questions, probably they will be. So maybe let's start with Festo. Werner, could you define what a smart factory is and explain this correlation between the IT concepts concerning individual machines and the entire production process?
Yeah, that's a very general question which I want to answer from our experience in our own production facility in Germany. And when we started with this new production concept and this new factory, we looked to the whole process. So we do not call a smart factory smart only because there are a few software tools working or some flat screens are around. We call it smart from the very beginning to the upper end. That means starting with for example, with the value chain and with the whole supply chain concept over the value stream concepts up to, let's say, most efficient, as good as possible, efficient maintenance process at the end, including also a concept for training and permanently further training of the production people, logistics, material flow. So the whole spectrum of what makes a factory efficient. This is what we call smart factory. That way, I would see it a little bit more holistic than just reducing it to the topic digitalization and IoT.
All right, thank you. That was very nice introduction, and I think that will help, and probably our other panelists will agree with your definition that it's not only about the digitalization part, but also other parts. But maybe in contrast to this, what you discussed, because everyone knows Festo, so this is a huge company, and someone can say it's easier for a bigger companies. So question to Piotr, is IoT, going to more into details, suitable only for large companies like Festo, or small companies and medium-sized enterprises also can benefit from its implementation?
Yeah, thank you for that question. As you mentioned rightly at the very beginning, number of years, I was the CEO of the global automotive supplier. We had 4,500 people, 10 factories, 4 continents. We were huge, and my job there was between 2011 and 2016, and I was absolutely sure that absolutely everyone, collect data about processes, and everyone knows what OE is and how to use it, and Lean is one of the main mindsets. And now I recognize, as a DBR77 CEO, and we try to introduce the technology to a huge number of companies, we recognize that especially IoT should be right now dedicated for small and middle-sized enterprises, because this is very, very rare that companies know their processes, know numbers, know statistics, standard times, know OE, know how to use the basic Lean strategies for their efficiencies. So generally, the answer for your question is yes, yes, yes. Absolutely, this is a time that all small and middle-sized companies should think about IoT as a basic solution, how to collect data. Especially that we should remember that all of the discussion about digital transformation right now should start with data collection, because this is the first step of any kind of digitalization, as the word means, digitalization. So we should work with our processes and our products based on data. Bartek, short answer is yes, absolutely every kind of company should focus nowadays on data collection, means implement some version of IoT systems.
All right, that's very interesting. And building on that story, I would like to address another question to Fraunhofer representative Simon. What are the potential benefits and challenges of implementing robot as a service solution for exactly small and medium-sized enterprises? this is something which we discussed previously, and I think it's super interesting for our guests to hear. So the floor is yours. So please describe this concept, tell about ups and downs, because I don't think there was only, only good stories. So bring us everything about this.
Yeah, thank you. And I think it fits well in the what my previous talker said about does SMEs have to digitize and go into digitalization. But I think we have to have a match-up process, because digitalization is a very important story. And we all say who does not invest into digitalization will not be part of the value chain in a couple of years. However, in the last couple of years, digitalization was not the major problem of SMEs. So they had a lot of other problems. And so the question is, how can IoT and the digitalization also go hand in hand with a higher level of automation? And this was a task for us because we see that there is a shortage of skilled labor, not only in Germany, but throughout Europe. And we were asked, is there the possibility of flexible automation? And why do we need it besides the shortage of skilled labor? What we see in the younger generation, there's a decreasing willingness to work on night or weekend shifts. And the younger generation in particular is explicitly looking for employers who does not require them to work in shifts. And secondly, we have highly volatile order situation, with some suppliers planning their capacity utilization on their plants with significantly less than a week's notice. So, and I can only react to meet these challenges if I can flexibly adapt the degree of automation in my production. That sounds quite simple here, like the example of lean before, but it does not work out so well in reality. I mean, we would be happy if it worked out that way, but I don't think any of us have ever experienced this that way. Because once we decided to start automation in production, there are several initial hurdles, especially for SMEs, that we have to overcome with solutions. Firstly, I don't want to replace my entire machine park on the shop floor just to have integrated automation solutions from the OEM. Secondly, when I have a shortage of skilled labor on the shop floor, I generally don't have a surplus of staff with expertise in control technology. And last but not least, automation solutions must be economically viable. I cannot pay, let's say, a factor of 10 for automation solutions that I would have paid for manual work. So we have taken on these challenges, and together with an industrial company, we created a solution that is able to overcome these hurdles I've just mentioned. And this is thanks to IoT and digitalization. The result is a robotic system that operates a machine tool very similar to a human, and therefore, for example, does not need a control interface to the machine tool, which is to be automated. This is a major advantage in Germany, but also throughout Europe, because in the case I would have an automation solutions that is directly connected to a machine tool, I have to do a recertification of the whole system in regard to safety. If there is no direct connection and the robot system itself is equipped with necessary safety devices and the machine tool was certified before, I can use them like I used them before and do not have any process of recertification. But what does it mean? My robotic system has to control the machine tool in the same way the human operator does. So it has to work with the HMI, for example. How do we do this? Our robot is hanging from a welding frame, so it can flexibly be rolled in front of a machine tool by a single worker for an additional shift. So please imagine you're in a company and you have the morning shift, and the morning shift does come to an end. And let's say you have several parts to be manufactured in a late shift. And what the operator does now, let's say 10 minutes before he finishes his work, he will roll our frame with the robot in front of the machine tool, and will also place the work pieces beneath the robotic solutions. For everyone who is interested, I can not show figures here, but can have a look on our homepage. I think that we can share this later on and can have a look at this system. And how does the operator now, or the robot now operates the machine tool? We equip the robot system with a camera, which is located near the end effector. So now we can collect all the information, all the data, by the visual inspection of the system. So what the robot would do, it would look to the signal lamp and would see the signal lamp is turns green. Now he knows he's allowed to open the door, the front door of the machine tool. We'll have a look inside the machine tool. Maybe it will grasp a finished workpiece, put the finished workpiece out of the machine tool and put in a new part. We'll close the door and press the start button. And how do we do this? We developed a new kind of control system. We call it skill-based control because it's a very good analogy to what the human operator does. We clustered the control call in small sequences, the skills. One skill could be grasp component. And the major advantage of the combination of a camera system and the skill-based control is that a human operator that is trained on the system, not a control technician, is able to program the sequences because the sequences are on a very high level of language. So you can program, grasp a new part, put the new part into the machine tool, close the door, press the start button. And all the necessary information in regard of positioning, the robot himself will collect from the camera information. So the camera information provides the color information and the depth information and can orientate itself in the existing system. So we can work in any brownfield environment without any problems. What is the major advantage from our experience with this system? When we talk about SMEs cannot afford most of the times high invest. So with our industrial partner, we were able to set up the system in a way that they develop a rental program. See, in that way, if you see an upcoming wave of high orders, you can call them and they will bring the system to your shop floor. And they will bring also a control technician. And the control technician will set up the first commissioning in your shop floor. And then afterwards, your technicians, your trained employees are able to do the recommissioning every time you need the system. And this is also in regard to the price, a good solution, because here in Saxony, quite close to the Polish border, we are able to offer this rental system for the same price like a human worker here. And
so
this is
a perfect trade-off, right? Because it seems like you mentioned you don't need to do anything with the machine, but you can replace directly the human labor with this robot, and it costs the same as a human labor, right?
This is the basic idea, yeah. And it's also very good for small companies to get a first experience with such novel things, because there's almost no risk. If they don't like the system, they will hand it over back, and the risk is totally on the side of the company. But the result is quite good for our industrial partners that no one would like to give it back.
Right. Thank you very much. That was a very interesting use case. So maybe now let's go to Alexander and discuss about this taboo topic, which is cybersecurity. Because during the implementation of any IT or IoT systems, we are facing this cybersecurity issue as I would say, totally taboo. No one is taking that much care as it is concerning, for example, the price, right, of the investment. And sometimes, in order to lower the price, we push the limit so that the cybersecurity is kindly reduced to the minimal scope. And what we hear increasingly about the cyber attacks paralyzing production lines and entire plants. So, in your opinion, what is the level of awareness in the manufacturing enterprises in this area?
Thank you for the question. So the cybersecurity topic, it's gaining in popularity, and it's, for me, it's very good. On the one hand, it's maybe positive because we become more aware in the cybersecurity area, but on the other hand, shows the scale of the problem. So maybe small fact, last week I read a report that provide CERT Polska, and in this report was information that industry or manufacturing is in the top 3 areas at risk in ransomware attacks. So right now we see the scale of the problem, and not just manufacturers are probably victim of the cyber attack, but also solution providers like us or the providers of the machines. So unfortunately, there is no golden mean and no single effective way to avoid a cyber attack. On the market, there are many frameworks, guides that teach us how to build safe IT ecosystem. But there is one thing that is the weakest point. It's us, user and human, and our nature. Our habits do not help us, because we always thought to react to the consequences rather than prevent them from happening. So according to the reports that prepared Sophos and VMs about 2024 ransomware trends, the ransom represent just about 30% of total cost that manufacturers must pay during the cyber attack. So we didn't see the consequences after, I mean, far reach. For example, hard to count PR losses. So interesting fact is that companies that taking part in the survey put information that 95% of them has a special team that is responsible for a response in accident, and they also have an attack plan. So my question is, how looks our reality? Are we good prepared to this like we think we are? So I don't want to be so depressing and sad during my speech, but I'm trying to highlight
it's
the
just
problem.
the beginning, so you can set the pace. Basically, we probably know that we will hear, it's very bad, and just it's like going to the doctor, right? You wait until you feel the pain, and then you go. And with the cybersecurity, it's almost the same from my perspective. And what about you? Just tell us, what is the awareness level?
I think what I see, and when I met with the companies since last year, I observed that IT, especially IT departments, are more and more aware and ask us how you provide the IT requirements, how you make safer the some tablets, PCs, visualization, and they ask us also in which technology you provide your IT solution. What will be IT security inside your solution? So right now I'm very happy, and I think we are heading in the right direction right now.
All right. So you see this trend is changing towards the safer
Yes,
environment.
it's very positive.
And the main lead is the IT department in most of the cases. Cool. Thank you very much. So let's move on and dig deeper into context of brownfield and greenfield projects. So maybe Werner from Pesto can help us with this discussion. What is the differences in the adoption of smart factory standards between those two? How it's becoming the widespread, and what is the main differences in terms of becoming smart factory in case of brownfield and the greenfield projects?
Now, let me start with a thesis or with a message we are at the moment presenting everywhere. This is called the systematic and predictive analysis of data will become a standard in all production. But then we have to distinguish between greenfield and brownfield. Standardization in brownfield is, of course, a little bit more difficult. As Simon explained it already, you have to implement into an existing production something new. So you have always a problem of interfacing, problems of standard protocols or whatever. And of course, because of the age of the machines, it can happen that you have incompatibilities in the data transfer. The greenfield situation means, from our point of view as a component supplier, this is the machine building world. So the machine builders who are designing new machines will also standardize this. That means for them, their IT concept around the machine will from the very beginning be designed to use the data, to get out the data in a systematic way, and to use the data in between the IT concept of the machine. Insofar, standardization is the key word for all of this, but greenfield and brownfield have to be separated a little bit from each other. Because if you're designing a new machine, of course, you have the latest technologies, you have the latest protocol standards, you have the latest interfacing standards and firmware standards. While in a brownfield, in an old production, especially at smaller and mid-sized companies, you have, of course, the problem, first of all, to get out the data from the different devices, especially from the controllers. Insofar, brownfield and greenfield both have their challenges, but at the end, in the greenfield world, it will become a little bit more easier than in a brownfield world. But also in brownfield, we will see this as a standard, more or less, in future, to use the data of the machines, to use more smart applications. This will become a standard solution. And this is why we are working very much on tools and little software products, we call them apps, helping the customer to install in a very easy way, even in a brownfield environment, predictive data analytics, for example. And
all right,
this is what we are doing for that.
So basically, what I'm trying to understand from your answer is basically the easiest way is always the greenfield, and that was something which everyone probably.
I would not say easiest, but a little bit more easier. A little bit more easier.
All right.
That's good.
Okay, and what about the brownfield? It means that this gap between brownfield and greenfield will be just increasing, right? Because if there is no standardization, or it's more difficult, so it means probably it is more more expensive in terms of investment. Then probably this gap between greenfield and brownfield project will just increase incrementally over the time, right?
I would not say increase. I would not say increase. I would say it will link each other more and more. Let's look to some industries like food and packaging industry, or the classic one is the automotive industry. Piotr, you know this very well. In the automotive industry, you have so-called power end users. That means the end user who is producing a car or is producing some food has the power to specify machine concepts to their OEMs, to their machine builders. And that leads at the end to a situation that even if there is a brownfield production, once they get a new machine, the ideal case is that this end user is then specifying IoT concepts or certain IT concepts in between their specifications, so that the machine builder is already requested to do a machine or to prepare a machine which is already IoT ready or artificial intelligence ready or whatever. Insofar, this has to do with each other. But I agree with you that in a pure brownfield environment where no new machines are coming in, it's of course a little bit a higher invest because some sensors are maybe not there, some interfaces are not there. Insofar, these companies have to invest. But on the other hand side, once you have invested, the payback period can be very short. Yeah, that means the investment is not that big. Yeah? And I speak here about the component level, I have to say. What Simon explained with a complete robot application is, of course, let's say half of the part of a machine.
Level, I would say, right?
Exactly, system level. We are speaking about the component level. And in the component level, yes, there is maybe necessary to invest in some hardware tools, even if it's only an IoT gateway or whatever. But this payback time is very short. Yeah.
All right, that's the positive outcome of this answer, right? So it doesn't mean that it's over for a brownfield project.
No, not at all. Not at all. So the worst thing is if you do nothing. The worst thing is if you do nothing.
Yeah, probably that's true, and I think maybe it's good time to ask Alexander from Ryan about the collecting of data and what you came up with as a Ryan, because you've created and developed your own IoT solution, which is quite similar approach for DBR77, because we've seen the same problem, which was already described by Werner. So it means that we all feel the same. So what was the approach from Ryan perspective to do so, right? And how difficult it is for you guys?
To build and develop our own IoT solution, it's interesting and risky because we always or very often ask ourselves one question: where ends and where begins the profitability to build our own solution? Because on the market there are many different kinds of IoT solution. We build one of them and provide to our customers.
Just to add one other thing is like IoT solutions is usually provided by the companies that are already specializing in manufacturing of some kind of sensors or other components.
Yes.
So they've got the know-how, they've got the big R&D, and they have probably better, financial background also.
Yes, that's right. But we have our strong background from our mother company that provides automatization in industry. So we try to build IoT solution. We want to see the balance between size, functionality, easy of installation, and the cost to the client, because sometimes we propose our solution. Sometimes we use the infrastructure that already is installed on the production plant. The main question is what we want to achieve, what data we want to collect from the machine. Because I am aware of advantages and disadvantages of our solution. Some customers want to collect just a few simple signals, and the Ryan IoT is perfect to them, or another kind of IoT solution. But some clients want to take from the machine program, tool number, or sometimes send some technological parameters to the machine. Ryan IoT will not cover this functionality, and then we need to integrate with different kinds of PLC. So as a provider, we didn't want to close ourselves to different possibilities to integrate with the machine. So to summarize, doesn't matter what we use. If we have the overall goal to give to customer benefit after this installation, we can use different ways and achieve the same goal.
All right. Thank you very much for this answer. And now I would like to ask Piotr about some thoughts about IoT. Maybe you can share our approach to our things we do. And also I would love to bring more another step to this discussion, which is if we talk about the data, how can it be monetized in the context of this industrial IoT solutions?
Thanks for your question. Honestly, I would like to discuss probably a little bit more even about robot as a service solution. So maybe we can be back later on or backstage about discussion like that, because TBR.
Or maybe we can discuss right now if it's not that long discussion, because it's all about discussion.
Bartek has his own concept of the session, and I don't want to ruin that. But 7 years ago, DBR77 started with robot as a service. I don't know if you're aware about that. That time in Poland, the average salary was like 800 euros. So it was, quite low. So we were dealing with companies which worked on 2 or 3 shifts. And even in such situation, it was quite challenging. And after spending more or less 2 million euro, I gave up. Yeah, it was so difficult from business perspective and risk management perspective, and technical also, that we gave up. And now DBR77 is a marketplace, digital twin, and IoT system. So I'm really interested about the future of your concept, and I do hope we can be part of that project also. But be back to IoT. As I said, I came from automotive, and all of my life, almost, I was the CEO. So my perspective for our IoT and data management is quite simple. We need to collect those data, which is important for us to increase efficiency. That's all. Yeah. But the question is, what kind of data we need for that? And quite often I speak with some partners and they say, we have a lot of data, plenty of them, which is actually not true, because when I see what people normally have, what company normally collect, they collect data which are important only for accounting, not so much for efficiency management. So what we need for that? We need, in fact, only two things. First of all, we need to know what is the cycle time, in order to compare cycle time to technological time or takt time in our plant. And of course, we need to know a little bit more about OEE, overall equipment efficiency. So what kind of data we need for that? We need, first of all, the information, what is the period for any kind of cycle. So in fact, we need to only find the same moment in any kind of cycle and tackle that moment, catch the moment when that the cycle is done, and we have cycle time. So this is one simple sensor. And second thing is OEE. And OEE is more complex stuff. And if you don't mind, I will share with you the solution which we did. Sorry for that. This is a little bit advertisement, yeah. But we ask ourselves what indeed we have to understand. And in fact, we recognize that we need only recognize it was one of 4 statuses. If I can ask for sharing my screen, it will be also quite helpful. Yeah? So look, we have the 4 statuses like working, change over, there is something is stopped, and there is a pause. Yeah, and in fact, in that simple way, by changing such simple statement, we can collect the data on the station if this is working or not working station. So what I'm trying to tell you is that we don't need a lot of data. And our approach is to make it really simple. Yeah, simplicity and plug and play solution for our clients. That was the main target, how we wanted to approach data collection. So we have a number of sensors. That sensors can be placed on the baskets, or can be placed on robots, or can be placed on, molding machine, whatever. Yeah, and then we have our systems which collect those signals. And then we have we call it wheel, when we can declare what is the status on the machine. And based on that simple 4 squares, we are able to recognize if the machine is working, is stopped, that stoppage was planned, or if it was accident, and what we can do with that. How we can monetize it? That's very simple. Yeah, if we start cooperation with the client and we see that OEE is like 45% or 47%, and by collecting data and understanding what is the problem on the production, we can increase that efficiency by averagely 20%. And I can honestly say 20% increased efficiency is quite usual for technology and the approach which we deliver to our clients. So when you increase that efficiency by 20%, very automatically you can recalculate it into the cost reduction or increasing of your production volume. And then in that way, you can simply see what is the financial results for such kind of data collection. I don't know, Bartek, if I answered for a question. I do hope I did.
Yeah, yes, you did. Maybe not directly, but I guess the main focus is when you use your data, you can improve yourself, basically. And what we know from our experience is like, firstly, you need to have a good data, validated data, data you can trust. So that's very important part, because if you've got average data around the longer time, then it's difficult to make any conclusions and to guess any improvement. So that's the data monetization, which I can understand. And maybe we can switch now to Simon with some deep dives into digitalizations and how manufacturers can encourage their suppliers to share the data and how this can be evaluated. So again, we will. My question is about how we can monetize the data in slightly different manner in practical aspects beyond only the scope of internal use.
Yes, thank you. I like Bert's approach because let me start with a small contradiction or seemingly contradiction, because there are many companies who don't know the easiest numbers of their production, like the OEE, like you said. But they are interested to have all the data their suppliers could hand them over. So they like to handle data from another company. Also, they don't know their own data. Why should we do this? And the idea was, in Europe, we should utilize our data above the borders of single companies to have something like a federated system to learn from each other to improve our overall efficiency. And you can do this from two perspectives. Like Werner said before, it could either be an OEM, like an automotive OEM, who tells to all of his suppliers, I want to have all of your data, otherwise you're not part of my value chain. Can be a method.
And this is easy. This is typical automotive case, right? And you follow the rules or you're not here, right? But the business is changing. So I think that also automotive will not do this any longer or with that intensity.
Definitely. And is there any alternative, like a positive connotation of sharing data, of learning from each other? I have not the overall solutions. I see that there are first solutions, but what gives me hope above all is the fact many of you may know the company Arla. It's a Danish company producing milk and products from milk like cheese. Anyone heard of that one in this panel? And the company is selling milk. And what has milk to do with data? They are paying a lot for the data of the farmers. So Arla is in the area of bioproduction, so they have to fulfill the requirements of biological production of the milk. And what they get is they ask their farmers to hand over the corresponding data per liter or per kilogram of milk, where they can see, because it's highly automated, the sector, with milking machines and so on, and feeding machines, and each farmer knows exactly which kind of food was eaten by the cow, which medicaments were, or which pharmacy was given to the cow, and how much milk was given by a cow per day. So, and Arla incentivizes this by several cents per kilogram of milk. And I looked the numbers up just before our meeting here. An average farmer in Denmark can make up to 40,000 euros per year with the data of his milk, his or her milk. So let me say, if the farmers and the milk industry can make such a high level of utilization from data of milk, such a simple product of our daily life, this should be motivation enough for us as engineers, as producing companies, to find those same use cases for our data, to share data across our or between our companies. And I see this is upcoming. We see this especially also in the aerospace sector, where we have low volume, high mix production, and where we have to learn from each other how to produce very complex parts to keep up the pace with American gigascalers, for example, with SpaceX or something. If we don't learn from each other, we will not make the race with the European space industry, for example. But this will come over to all other producing areas where we can also utilize AI in a much better way if we put all of our data together as a learning basis. I don't want to share the deepest details of my own production, but if we can find methods, and we have already some methods for this, to do like an anonymization layer of my data so that anyone external cannot draw conclusions about my specific production know-how from this data, but we can use this to learn artificial intelligence models, let's say not only from my company, but from 10 other companies besides me. We have much better models that we can then again use to optimize our own production. So here there's a big playground.
So we're speaking about major shift in terms of consuming and exchanging the data, because it seems like it's not only about the company level, it's about Europe as a whole, or even industry as a whole issue, right?
Yes, definitely.
Right, great. I love this case, Simon. It's that much eye-opening that when you need to pay for data when you're a manufacturer of the milk, then it's really a gold mine when you have more advanced products. So for example, I think that next part will be medical products, aerospace for sure, maybe some other industries which are also heavy interested in the traceability of the product during the supply chain. This is amazing. So in order to move on, because we've got a lot of questions to be discussed, so let's go maybe now to Alexander, and basically we are going into the nitty-gritty details about the implementations, use cases. So basically, can you share any interesting or inspiring story of the industrial IoT implementation you've been involved in? What were the issues there? What was the final outcome?
Yes, of course. Thank you for the question. The story is very strong correlated to what Piotr said. I mean, during implementation,
we collect. It's again about the milk. Okay.
But implementation is in a food company, candies. So we are near the topic of the food concept. But I want to mention what Piotr said. I mean, we collect just a few simple signals: cycle time, machine on off, changeover. That's all. And the question is how we can monetize this implementation, how we can show the benefit after implementation. So 2 years ago, we start our cooperation with one of our customer. We choose the one line where we start the pilot. This is the most efficient line. We choose this one because we can see very fast the benefits. So we implement just a few signals, collect just simply and basic dates from the machine, and the benefit after implementation was 60% time reduction on changeovers during the shifts on the whole month on this machine. So I want also here highlight the customer, because he guide the operators and properly communicate the implementation. So employees were very involved during the project, And this probably give us success of this implementation. When we see the benefit on the one line, it was easier to go to another lines. Yes, exactly. But it was not like simply copy paste, because there was a different lines from different providers. So sometimes we integrated to PLC. Sometimes we add some sensors because machine was very, very old. And sometimes we provide them Ryan IoT, and we are flexible to choose the solution. Right now, we also provide extra functionalities to this client. So we start and monitor utilization of the media. So right now we're going into details. We're just focusing on the operation costs, because the OE we leave behind and we increase the OE. But our solution is not just remedium for every problem. The knowledge, the whole effort that customers put on this implementation, it was their success. So the solution provides verified data, but the all actions, optimalization, etc., that made the customer team, so is their success.
All right. 60% sounds like a great example. So it already proves what Piotr said, or what all the other panelists said, that this data approach is benefiting the companies in real examples. So maybe now let's move on slightly into other topics. Werner, I've got a question. In your opinion, where does the industry currently stand in the terms of the smart factory adoption? We already discussed that we see very different approaches and different level of implementation. So in terms of your experience, is this more hype or is it the reality? Does company really benefit of this smart factory adoption? And could you provide a use case to illustrate this thought?
Yeah, it's a really good question. And as I said before, the principal question is not to do digitalization, whatever that means. The principal question is to do at least something. And if we say, what are the companies doing? I would say nearly all companies, and the statistics shows very clearly, up to 60-70% of companies, independent from the size, are doing at least something. Yeah, and that's a good sign. Insofar, it's reality. It's a request in modern automation technology and production technology to do something. A real use case. So we have several hundred projects running the last years with different kinds of companies all over the world, and I would say there is from 0 to 100%. There's everything. We had a lot of projects where even the customers stopped the activities because they said, we do not really see a benefit in, for example, analyzing the data of a single machine. And that's exactly the problem. If you do it just for one single application or one single machine, you have difficulties to calculate the overall approach. But let me take an example from the other side. So
the answer is a typical consulting answer. It depends, right? Could you?
Yes, it depends. But a small company who is just trying out something has something more difficulties to calculate the benefit than a big company who sees from the very beginning the rollout potential. If you roll out it and deploy it to the whole company, and there we have currently a project.
So that's the key distinction, right? So we need to have a plan in our mind and know how we want to go from point 1 to 2, and then combine those blocks together, and then we see this final effect.
And from the very beginning, not trial and error projects, please, because from the technology point of view, sooner or later, everything works. That's not the challenge. The challenge is the rollout and deployment to the whole production side. Means from the very beginning, there must be a clear plan of rolling out a certain concept to all of the 100 machines or all of the applications. And then you get immediately also return on investment, and you see immediately a result. For example, if you analyze only 10 cylinders in a big automotive factory, you won't see any result. You can analyze the data for 100 years, you don't see something. If you consequently deploy the solution to all 5,000 pneumatic clamping units, which are typically in an automotive plant, then of course you will see immediately an effect, because at least the clear fault location and the fault classification can help immediately to reduce the maintenance effort by 10-20%. And that's a huge number if you look to such big production plants. Insofar, the clear message is, yes, it's reality. Everybody's doing something, but the trend is clear. We are going away from trial and error projects by some apprenticeships to a more conceptualized rollout into the entire production plant of a company.
That's super interesting story, and thank you for sharing that. So maybe let's stay in the terms of case study. So Simon, could you share any case study highlighting some successful implementation of IoT in the industry, and maybe some relation to what was said already by Werner? Because this approach is really nice, and I would love to hear from you how it was.
Yeah, and I think it goes in a quite same direction of Werner, but not the same. Because I once again come back to sharing data along a supply chain, for example. And we worked with several bigger companies who wanted to collect the data for quality assurance, let's say. And they asked their suppliers to deliver a certain data. I cannot mention what it is here explicitly, but it was sensory information they like to have. However, in the first time, it's a couple of years ago, they tried it, and they did not specify in which format and how this data was to capture. And this was a major problem, because the suppliers delivered some kind of data which was correlated to the product and to the quality of the product, but was not readable for anyone outside the company, not because the digitalization was not readable, but there was no knowledge around this data. And we helped these customers to standardize, and I think this is also mentioned before.
So you mean that there was a data, but no one could understand or decode it, or that is that the case? You had all
no
the
one
data
could understand it because there was no enrichment with knowledge.
All right,
So
that sounds
we
like
had
a
some
nightmare,
data.
right?
It was a nightmare, and they tried to do the reconstruction of the knowledge in the company itself, and not to give too much information what they really like to know. And we helped them to develop a standard, what they can ask their suppliers for in terms of the enrichment of data. And this is what will be the direction. We need certain standards, and I think there we will need also the bigger automotive OEMs to set up these standards, because this can help to set the pace.
So this is the typical, I would say, German way. Standard, you need to follow the rules, and this is a very good approach. In Poland, we do it slightly different, but I think that's the case taken. And thank you very much, Simon. It's extremely interesting, and maybe
but
just for wrapping up, because
do not underestimate the Polish way. So it's much more pragmatic, and I like pragmatic. So please keep on your pragmatic ways. That's very recommended.
We always tend to be very fascinated by. We would love to be like Germans with your standard, but at the end we do it our way. It's like, we've got standard written. Okay, this one doesn't apply. Let's move on. Okay, but we've
And
got
this is a
just
good way
1
because
minute left.
we have oftentimes we have too much standardization and it takes too much time to find these standards. So I think there has to be like a golden way in the middle, not to do all on our own and on a pragmatic way, but not also to do a standardization for everything in before.
Yeah, exactly. So just to wrap it up, last question to Piotr, because what do you envision for the future of IoT? And please keep it short because we've got like less than 1 minute to finish.
I love when somebody asks me for future prediction and give me 50 seconds, which is absolutely impossible. Before I will do it, maybe I will also tell you some surprised information why Bartek likes standards so much. Number of years he was responsible for BMW projects in Poland. So he worked for German markets so many years, and he came from south part of Poland, which is, let's say, in half German. So maybe that's small joke at the end. Yeah, but a couple of words about future. I would like to share with you my screen, if that would be possible, and I would like to show you what I believe it will be the future. And I would like to cover two technical stuff. First of all, we spoke today a lot about data, but we didn't mention anything about synthetic data. What you see here, this is our digital twin, and our digital twin looks at the factory on a logistics center as a complete system. And in that way, we are able to agree to rules, how the systems, how processes are organized, and we are able to make simulations. Automatically, we can change assumptions, and in that way, we are able to collect a lot of data as a result. The result of that action is huge bunch of data. So, for example, Werner mentioned, of course, when we have very small number of information, we need a lot of time to find any consequences, find any rules, any pattern. But when we can do simulations automatically, we can do it much faster. So of course, the question is if we are able to do simulation which really present the real world. And right now, I mean, last 2-3 years and probably next couple of years, we are crossing some river and we are able to really simulate, really write stuff and see how that artificial world, I mean digital twin, can represent real one. So I think that that technology will open a lot of new possibilities, not for data collections, but for data creations. But well created data can be as efficient for us like actual data. That's the first point. And second thing, I think that second idea which I have in my mind is systems which we call cameras with LLMs. Because, you know, guys, if we are able to understand vision much better than it was possible 2-3 years ago, probably we can make much more conclusions. So, you know, now we have a lot of sensors. We collect data by stuff like that. But can you imagine when we can place cameras on the roof and not stream the video, but place LLMs inside that cameras and try to understand much better what the cameras see? I personally believe that in 2-3 years from now, we will have such technology. We as a DBR77 will work on such technology as well. And then it's huge change in data collection and moreover, data understanding. So both two things like collect data from visions, understand by LLMs, and digital twins for creation new data. I think that is whole future in front of us.
All right, so we are slightly over the time, but it was a very interesting panel. I think that our guests will share that. And I would like to thank you guys because it was very insightful. I love that we didn't agree on everything. So this is a good thing, right? Because it's always we have some contradicting thoughts. And thank you very much. It was super cool. And if you are willing, just be available on chat to discuss with our guests some knowledge. And thank you very much, guys.
Thank you.
Thank you,
Thank you. It
gentlemen.
was a pleasure.